Ladies and gentlemen, this is part 2 of 8.7 function notation. So if we're looking at these two graphs real quickly, we're going to be comparing speed of typing from your typing speed to a teacher's typing speed. This is a fictional. I type decently, but I don't think I type quite that quickly. So no, it's not about me. So this is T for teacher. Okay, so I'm telling you a couple things is find the unit rate for each. And that would really help. And you can also use slope in these examples. So let me see. If I come over here, where do I cross exactly? 2 minutes. Okay, so what I'm doing is I'm just placing points where the lines intersect nicely with the line that's graphed. So I can say easily at 1 minute, you're able to type 30 words per minute. So I can even say that 30 words per 1 minute, right? That's a rate of change. It's a unit rate, and in this case, it is also the slope. Because for every 30 I go up, and I go over 1, I cross. If I go up 30 and over, I should cross. So if I go from 30 to 60 and over 1. Sorry, I was thinking that box was 1, so that's over 1. So up 30 over 1. So up 30 over 1. So that works that way for me. I'm going to change my pen just so that we can see if I'm making marks which one I'm talking about. So let's do green. So this is the teacher's typing. So if I was to graph this at 3 minutes, oh, she's going to be way off the chart here, right? So it's going to be really hard for me to graph that. So if I can say, well, for 3 minutes, she can type 210 words. I can do a couple things. I can simplify. I can take this to the unit rate, and that is 70 words per 1 minute. Do I have two things I can compare? I certainly do. The other thing I could have done is I said, okay, at 3 minutes, I can type 90 words. Then I could have said, well, at 3 minutes, she types 210. She's typing more words because she's faster because she's getting more words typed per minute, which goes right there with the explanation. So hopefully that's not too confusing and it makes sense to you. And let me pull my thing. Okay. We really just were trying to figure out who was typing faster, and that one was pretty easy just by looking at the unit rate. And that is, in that case, the slope. Over here we're comparing functions. We want to compare the equation for this line to this function or this equation, which is f of x equals 1/4 times x plus 1. And they just want to see how do the rates of change compare, how do the y-intercepts compare. Okay, so I plotted some points where these are connecting with the lines, where the line intersects two of the points nicely, the x and the y nicely. So I can see this one apparently is starting at 2. So what does that tell me? If it's crossing the y-axis at 2, I can write this as how? That would be my plus 2, right? This is going to be my b. If I look at the equation f(x) equals mx plus b, 2 is my plus b, so it's starting at 2. And so I know I have an x, and I know I'm going to have f of x, which is just a fancy way of saying y. If I go up 1 over 2, up 1 over 2, so rise over 1, this is 1/2. So I want to compare the rate of change, or in this could also be known as the slope. How is this changing? The rate of change, the slope. Well, this is 1/2 and this is 1/4. Now, if you're not sure what that means, let's graph this 1/4 then. So that means we're going to make a table. Okay, so I made a quick table while I paused it real quick to make a table. So I have x and y. If I put 0 in for x, so f of 0 equals 1/4 times 0 plus 1. Well, anything times 0 is 0. So f of x, or y, equals 1. Then if I say, well, let's do 4 because the denominators are 4. 1/4 times 4 is 1. 1 plus 1 is 2. So f of x, the fancy way of saying y, is 2. So now I can go through and graph this. I can say, well, at 0, I go to 1, and then I go over to 4, and I go up 2. So because remember x, y coordinates is, what this is. So that's why I'm graphing it like that. So then I'm going to connect a line, and I have a fancy dancy little line maker. So let me grab him. Oh, look at that. Oh, that's a little too big, don't you think? Let's try something a little smaller. No clue he was going to be that big. We'll just go with basic. So if I connect these 2 points, I can see that these are definitely 2 different types of lines, and I can tell that this one is increasing at a much slower rate because it's not steep. The hill is not steep. This is increasing quicker. So I know that this one down here is changing at a slower rate. It has less of a hill compared to the initial one. How do the y-intercepts compare? Well, this is shifted by 1 unit. This line starts at +1, and this one starts at +2. So they've shifted by 1 unit. Okay, ladies and gentlemen, this last slide is your video check. I would like for you to, on your homework paper that you just turn in, which will have 3 problems from, I believe it's page 253B, that you're going to fill in. And I'm double checking real quick. Sorry, 453B, problems 1 through 3. So problems 1 through 3 on page 453B. And this at the top of it, if you'll have this written, and if you'll put just a box around your answer, you don't have to write this whole screen down, just your answer. How many weeks will it take if you're saving at $12 per week? How many weeks at $22 per week? And in that box, if you'll label it video so that I can easily give you credit, because some of you are doing, well, everyone's doing a different way of doing this. This will make it, I give you video credit, and as you're starting to work this, you're going to realize, Mrs. Lattimer, you did the work for me. I only had a little bit of counting to do. That's because you've been a phenomenal student and you've been watching these videos to the end, and I appreciate that. And I wanted to give you a little break and say great job for doing a great thing for yourself. Thank you.